In July 2024, one of the most significant natural disasters in recent years unfolded in China, a massive flooding event along the Yangtze River, which put extreme pressure on the Three Gorges Dam. This flood is not only a disaster in terms of its immediate impact on communities and infrastructure, but also tests the limits of engineering design and flood management systems that are meant to safeguard millions of people. The Three Gorges Dam, the largest hydropower project in the world, plays a critical role in managing water flow and providing electricity to the region. However, as the rains caused the Yangtze River to swell to unprecedented levels, the dam faced its biggest challenge to date. The flooding has affected major cities, disrupted transportation, and raised serious concerns about the dam's capacity to handle such extreme weather. From an engineering perspective, this situation reveals the complexity of flood management, the resilience of the dam's infrastructure, and the challenges posed by climate change and extreme weather. Today, we'll break down how the Three Gorges Dam is designed to deal with such events, the immediate engineering response, and the long-term strategies engineers are using to prevent future disasters. The Three Gorges Dam was built with the primary purpose of flood control, alongside power generation and navigation on the Yangtze River. By regulating water levels and controlling the flow of the river, the dam helps prevent seasonal flooding, which historically affected millions of people in China. However, the recent floods exposed the limitations of even the most advanced flood control systems. The cause of the flooding is linked to exceptionally heavy rainfall in the summer of 2024, which led to the river's water levels rising rapidly. The Yangtze River saw an influx of water volume that far exceeded typical seasonal flows, overwhelming some flood prevention measures. Engineers were forced to adjust the release of water from the dam to prevent catastrophic overflow, a decision that carried risks of its own for downstream communities. One of the most challenging aspects of this flooding event is the sedimentation within the river. Over time, sediment buildup behind the dam reduces its capacity to store water. When water levels rise too quickly, the dam must release water in a controlled manner to avoid the risk of dam overtopping or structural failure. The sediment and water combined create an added stress that engineers must continuously monitor, ensuring the dam's safety throughout extreme weather events. Short-term engineering response. When the floodwaters began to rise, engineers had to take swift action to manage water levels and prevent further damage. The most immediate engineering challenge was to regulate the dam's reservoir by controlling the discharge of water. Floodwater management. The Three Gorges Dam is designed with a spillway system to release excess water safely. When the floodwaters began to exceed the normal storage capacity, engineers used controlled releases to maintain the integrity of the dam. This process is delicate, as releasing too much water too quickly can lead to dangerous flooding downstream, while not releasing enough can place undue pressure on the dam's infrastructure. Real-time monitoring and data engineers rely heavily on monitoring systems that include inclinometers, hydraulic sensors, and satellite technology to track the dam's structural integrity. These systems monitor water pressure, dam deformation, and water levels in real time, ensuring that engineers can make decisions based on the most up-to-date information. Early warning systems have been critical in preventing worst-case scenarios and coordinating emergency responses. Structural integrity of the Three Gorges Dam. The design of the Three Gorges Dam is meant to withstand significant stress. But even this cutting-edge engineering faces challenges during extreme events like the 2024 floods. Dam design and safety protocols. The dam was built to handle major water surges with reinforced concrete, rock-fill construction, and an innovative multi-stage spillway system. While these systems are highly effective in managing regular flood levels, extreme events push the dam's limits, and ongoing structural monitoring is crucial to ensure the dam doesn't experience overtopping or structural fatigue. Risk management. Engineers are constantly evaluating the risk of overtopping, a scenario where the water level exceeds the dam's capacity. Though rare, overtopping can lead to catastrophic failure if not managed properly. During the 2024 floods, engineers carefully monitored water levels and increased discharge rates to avoid reaching this dangerous point. Long-term mitigation strategies. While short-term measures focus on immediate risk management, the challenge of sustained flooding requires long-term planning and adaptation. Upgrading dam infrastructure. With climate change expected to increase the frequency of extreme weather events, engineers are looking into upgrading the dam's infrastructure. This includes increasing storage capacity, upgrading spillways, and enhancing sediment management systems. These upgrades are essential to ensure the dam can cope with larger-than-expected floods in the future. Sustainable flood management. Long-term flood management strategies also involve reforestation programs along the Yangtze River basin, improving upstream water retention, and enhancing coastal flood defenses. These efforts reduce the amount of water flowing into the dam during heavy rains and help mitigate the effects of climate change by stabilizing the region's water flow. One of the most important tools used in the management of the Three Gorges Dam is advanced technology. Engineers are using a combination of artificial intelligence, machine learning, and hydrological modeling to predict future flooding events and improve operational efficiency. Predictive modeling. Engineers can now predict flooding events months in advance by using machine learning algorithms that analyze weather patterns and past flood events. This predictive capability allows engineers to adjust the dam's operations well in advance, optimizing water storage and discharge rates. Hydrological modeling. Hydrological models simulate the river's flow and help engineers assess the dam's behavior during floods. These models are critical in guiding decisions on how to handle water releases and manage the long-term stability of the dam. The 2024 floods have not only posed technical challenges, but also significant human and environmental impacts. Thousands of residents downstream have been forced to evacuate due to floodwaters, and agricultural lands have been submerged, leading to crop damage and economic loss. The environmental impact is also a concern. The flooding has resulted in decreased water quality, habitat destruction, and changes in sediment patterns, which affect aquatic ecosystems. For engineers, managing these risks while continuing to operate the dam in a safe and sustainable way remains a delicate balancing act. The Three Gorges Dam flooding event of 2024 has highlighted both the resilience and limitations of large-scale infrastructure in the face of extreme weather. From real-time monitoring systems to upgrading infrastructure, this event serves as a reminder that engineering solutions must evolve as environmental conditions change. For engineers, the key takeaway is that long-term planning, technological innovation, and global collaboration are essential to ensuring that hydropower projects like the Three Gorges Dam can withstand increasingly frequent and intense flooding events. The lessons learned from this event will guide future infrastructure design, ensuring that these projects remain capable of handling the challenges posed by both natural forces and climate change.